Hi, good morning, everyone. So today I will continue chapter 5 with the last chapter 5.4, which is the application of vectors in geometry. So as you can see in this chapter 5.4, we will learn 6 subtopics. As you can see, the first two is study about line. The 3 and 4 is study about the plane, and 5 and 6 is study about the relationship with line and plane. So we'll start now with the equation of a line. So to find the equation of a line, we need a 3 point, which is a point at simply a point at along the straight line. It can be here, it can be here, it can be here. So we name it as R with the coordinates x, y, and z, and a fixed point which is stationary, cannot move. We name it as A with coordinates x1, y1, and z1. So these 2 points form, when they join together, form a straight line. So, and their direction vector is, we name it as V with the AI plus BJ plus CK. So as you can see, the vector AR is parallel to V. So we name the T as the scalar. Why we name T as a scalar? Because later we will find the parametric equation. Have you remember the parametric equation in last sem, chapter 9, differentiation? Yeah, we just use back the parametric. So we name the T as scalar. So AR equals to TV. T can be any number and any real number. So AR can be written as OR minus OA. And we rearrange the equation. So OR equals to OA plus TV. For OR, we can written as small letter r, and OA we can written as small letter a. So R equals to A plus TV is the vector equation of the straight line. For R, just now we said the R has the coordinate of x, y, and z, is it? So it also can be written as xy plus yj plus zk. So A can be written as x1y plus y1j plus z1k. And the AI plus bj plus ck, this is the direction of vector, which is v. So we compare the coefficient of ij and k. So we have x equals to x1 plus ta, y equals to y1 plus tb, and the last z equals to z1 plus tc. This is the parametric equation of the line. So from this parametric equation, we take out the t. You can see the scalar t, right? So we take out all the t. T equals to x minus x1 divided by a. Also same as y minus y1 divided by b. Also same as z minus z1 divided by c. So this is the Cartesian equation of a straight line, or it also have another name. It's called the symmetric equation. But this usually we use the Cartesian equation more. The question also asks Cartesian equation more. Very less or almost no question ask say about the symmetry. It's not so common, but it's better that you memorize too. If really cannot, so you memorize the Cartesian equation. Okay, so I will prepare some question. So we go to the question. Okay, so find the vector, parametric, and Cartesian equation of the line passed through A and parallel to 2i minus j plus 3k. Okay, so we need to find the vector, parametric, Cartesian. So for vector, just now we have learned r equals to a plus tv. So you see which is the a, the point A, this is the fixed point. So the A can be written as I minus 4j plus 2k and parallel to 2i minus j plus 3k. This is the direction vector, so it is V. If you scare you don't know how to solve, not so familiar, so we with the formula, so you can write down the A, the V, and the R is the free point. Can be any point on the line. So R will be xi plus yj plus zk. So for vector, wait, let me erase it. Okay, so the vector will be, you can write as R or xi plus yj plus zk. These two form also can. Okay, so the R will be I minus 4j plus 2k plus t multiplied by 2i minus j plus 3k. Or this, you want to write the R as xi plus yj plus zk also can. For this question, I choose to write this second, because I need to find the parametric and Cartesian. So if I write xi plus yj and zk, so I have write out the coefficient of ij and k, so I can just straight away compare the coefficient. X, this nothing, so it be 1 plus 2t. The y equals to minus 4 minus t. Don't forget to write the t. Minus 4 minus t. And the last one, z is 2 plus 3t. So this is the parametric equation. So for last, we take out all the t. So we will get t equals to x minus 1 divided by 2, or y plus 4 equal to divide by negative 1, and also same as z minus 2 divided by 3. So this is the Cartesian equation. Here's the answer. Okay, so we go to the second question. Find the vector equation of line passes through points A and B. So they no say the A or B is the fixed point. So for me, for me, I usually prefer to choose the point who's come first, who's come first. So who will be the fixed point? Yeah. So in this question, A come first, so I take the A as the fixed point and B as the free point. So I write the A and B as in the vector form. I plus 2j plus k. This is minus I plus 3j plus 2k. Okay, so we find the vector AB. So vector AB equals to vector OB minus vector OA. So it will become negative 2I plus j plus k. So vector AB is same as this B. Can write it as B also. So the R is equals to A plus dV. So just now I say I take this A as the fixed point. So I put sub this A as this small a. I plus 2j plus k plus t multiplied by this vector minus negative 2I plus j plus k. So this is the answer. Okay, so we go to question 3. A straight line with vector equation r equals to 2I minus j plus k plus t multiplied by I minus j plus 2k passes through point A1B. So A and B are unknown, so we need to find the values of A and B. Okay. For this R for this R as like it can be any point on just now I say any point on the straight line. So I put xy plus yj plus zk. So it passed through the point A1B. So I sub A as into x, 1 into y, and b into z. Let me change. Hello, okay. Here. So we comparing the coefficient of I, j, and k. So we get, okay, why I compare the j first? Because the j does not have any unknown. Here is 1, here is negative 1, here is also negative 1. So before I find the value of a and b, so I need to find the value of t first. So I get the t equals to negative 2. So now I have the value t. So I sub the equation of equation, sub this t as negative 2. So I get a equals to 0 and b equals to negative 3. Okay. Okay, so we go to the angle between two straight line. Okay, just like the scalar product we learned at chapter 5.2. So we know the vector equation of two straight lines are this R1, R2, A1 plus T V1, A2 plus T V2. So for this, we take the direction vector, so we just take the V1 and V2. So the angle between R1 and R2. So you just see back the dot product. So theta we can, okay. So to find the angle, we need the dot product of the two vectors and the magnitude of each vectors. So let's go back. We just sub the we just sub this angle between two vectors. We sub this A and B as V1 and V2, so we can get theta equals to arc cos V1 dot V2 divided by magnitude V1 and magnitude V2. Yeah. So let's go to the question. It's simple. You just use back Just use back how like how 5 by 2 ask, so how this 5 by 4 will ask is similar. Just ask for the theta or the acute angle. So you go to the question 1. So find the angle between two straight lines, R1 and R2. Okay, just now I said, so to find the equation of two straight line, we need to know the direction vectors. So the direction vector of R1 is I plus J plus K, is sorry, B1. And for R2 is 2I minus 3J plus 4K. That's B2. So you know that the V1 and V2 for this question, because yeah, I more like to use this column because it's simple to see. So without the I, J, and K, so I write it is in column form, so easier for me to see. Or if you want, you just can just write as I plus J plus K dot 2I minus 3J plus 4K. But this is more complicated to see because I don't want to see the I, J, and K. It's complicated, so I just write it as column form. Yeah, more easier to see. 2 minus 3 plus 4, so equals to 3. So the magnitude of V1 is sub 3 and V2 is sub 29. So I can get the angle is a cos 3 divided by sub 3 multiplied sub 29. So I will get 71.2. Yeah, it's just easy. It's easy, just as you use by the knowledge of 5 by 2, the angle between two vectors. So don't get confused. Okay, let's show. Okay. Okay, so it's end of the study of the line. So next we will go to the study of the plane. Yeah, equation of a plane. So the plane is this rectangular thing. You just imagine this diagram in 3D form, and this plane is lying on the surface. So each plane has a normal vector and n is the normal, which the normal vector is perpendicular to its plane. So the normal vector fixed point, pass through a fixed point with written as A, and a free point which is at R. Sorry, just line. So the AR is perpendicular to this normal. You can see it's perpendicular. So the dot product between them are 0. Like just now, we separate it as OR and OA and can be written as small r and small a. So we will get r dot n minus a dot n equal to 0. So r dot n equals to a dot n. So the r is you can see r is the x, y, z. The n is the a, b, c. And the a is x1, y1, z1, the fixed point. Just now, Rn equals to An. This is the vector equation of a plane. And wait, let me use another color. Okay, let me use another color. And the Cartesian equation of the plane is ax plus by plus cz equals to d. This common is common in the question. Usually the question will give the equation of plane in the Cartesian form. And the B, C is, you write it as ij and k, coefficient of ij and k, so it will be the normal. So this plane, we can write is in pi also. Ax plus by plus cz equals to d. So d will be the ax1 plus by1 plus cz1. Yeah, this is the dot product between the a and n. Here's the relationship between the normal vector and the plane. Yeah, I just draw it here. The relationship between the normal vector and the plane. So to summarize it, so the equation of a plane requires a fixed point and the normal vector. So we can conclude that the equation of a plane can be written in two forms. The first is vector equation and the second is Cartesian equation. Yeah, I highlight it in green color. So we look the question. So find the vector equation. Find the vector equation of the plane with normal vector 5i minus 3j plus 7k and containing the point A. So I write the normal vector as n. I write down first, so it's easy for me to start in the formula. And A, write this in the direction vector, negative 5i plus j plus 2k. So by using the formula, Rn equals to An. Yeah, for me, I like to use the column form. So 5x minus 3y plus 7z equals to 25 minus negative 25 minus 3 minus plus 14. So I will get negative 14. So I rewrite it in the vector equation form. So I will get this R. Okay, use the vector equation. And second, find the vector equation of a plane pass through point A and perpendicular with the line, this line. This parametric equation, okay, is another asking method. But it's same as question one. Just you know that the normal is perpendicular to this plane with this point A. Yeah, so this, okay, for this, we look back, the n is written as AI plus BJ plus CK. And this parametric equation, just see back, is written as x equals to x1 plus ta, y equals to y1 plus tb, z equals to z1 plus tc. So we find the a, b, and c come out. The a is 1, b is negative 2, and c is 3. So I write this write this n, the normal vector, as I minus 2j plus 3k. And the a is from this a. I plus 2j minus 3k. So you see, I use the R dot n equals to a dot n. Okay. So x minus 2y plus 3z equals to 1 minus 4 minus 9 equals to negative 12. So I write this answer. Okay, so the third, find the Cartesian equation of the plane passes through the points A, B, and C. Okay, another asking method is different a little bit because it does not give the line, it just gives 3 points. Plane pass through, Cartesian equation, the plane pass through A, B, and C. So yeah, this A, B, and C is line on the plane. So to find them, so I need to find the vector of AB and the vector of AC. Yeah. So the vector of AB is 3i minus 2j plus. I use 3i minus 2j plus k. And the AC is 5 minus a 5i minus j minus 2k. I get it from here. So we need to find the normal vector. So we learn from the vector product. So to find the normal, we need to multiply the vector AB and AC. This is the normal vector. So we multiply, so we will get, we use the matrix, and we will get 5i plus 11j plus 7k. So you get, so now you get the normal vector and the A is which the fixed point. Just now I said who come first, which point come first, so I use that point as the fixed point. So I get A because A come first, so A equals to negative I plus 3j plus k. Just sub into the formula Rn equals to An. So I will get 5x, 5x plus 11y plus 7z equals to 35. Is the answer? Yeah. For this question, if they ask 3 points, they give you 3 points, so you need to find the two vectors and one normal equation, and you find the fixed point. Okay. Okay, so let's go to question 4. So find the Cartesian equation of a plane. Yeah, just now 3 question we find the vector equation. So now we find the Cartesian equation. So pass through the point A. A is the fixed point. So the A, okay. Oh, sorry, just now the question 3 we also find the Cartesian equation. A equals to 4i. This 0 no need to write, so straight away 2k, negative 2k, and perpendicular to the two planes. Yeah. Now they give you two planes and 1 point. Okay. So Okay, just let me draw it. Mm, is this like that? Okay, for never mind. Just know that this plane is difficult to draw. This plane is like intersect and need to find the vector. So we need to find the cross product between the n1 and n2. So the cross product between the n1 and n2 from these two planes, so it will become 3i plus 6j plus 3k. Use back the formula Rn equals to An. So I will get 3x plus 6y plus 3z equals to this AA is just now 4i minus 2k, 4i minus 2k, and dot with this normal, so I will get 3x plus 6y plus 3z equals to 6. So divide by 3 to simplify it, so I will get x plus 2y plus z equals to 2. Sorry, the keyboard has just always come out. Okay. So the question 5, find the Cartesian equation of the plane. Okay, got A and B. So the first is pass through point A and parallel to the exact plane. So for these questions, they ask the parallel to the exact plane. So the final answer will be Y only. Yeah, use the same concept. So it asks the parallel to XY plane. So your final answer, your equation will be Z only. So Y will be like this. So you just see. So the direction vector of A is 6i minus 7j plus 4k, and the normal vector will be j only, 1j. No this exact, just the y. So we sub this Rn equals to An. So because the x is 0 and the z is 0, so the final answer, we will just get the y with equals to negative 7. And for B, contains point A and parallel to this plane. Parallel? Yeah, they parallel. Okay, so for this question, like SA, yeah, it also the same. Just find the A and N. And just use back the Rn equals to An. So I will get 4x minus 2y plus z equals to negative 5. Yeah, it's simple. So for the question, if they ask exact plane parallel to exact plane, the final answer will be y. And the normal vector, the coefficient of I is 0, and the coefficient of k is also 0. Exact plane. Let me draw it. Let me try to draw it on the spot. Exact plane. Okay. like this, or so the x will s and z will be 0, and only the y got here. Okay, I just simply draw it. Okay, so we go to the last question. Find the Cartesian equation of the plane containing the line and the point. Okay, for this question, you need to obtain the fixed point, a free point, and a vector. So the fixed point will be this 2i plus 4j minus 3k. So I write it as q, and the free point will be p, and the vector. So let me find the pq, the vector pq. pq. So the OQ minus OP, so you're written by this. So I will get the PQ equals to negative 5i plus 7j negative 8k. And the normal will be this direction vector multiplied by this PQ, this OP and OQ. So the normal vector will be straight. So use the matrix form. So I will get negative 4i, negative 4j, negative k. Yeah. Use back this r dot n equals to a dot n. So I will get negative 4x minus 4i minus z equals to negative 21. So I want to remove this negative to make it look nicer. So I divide it or multiply it as by using negative 1. So 4x plus 4y plus z equals to 21. Yeah. So conclusion for this question. So if they ask containing the line and the containing a line, yeah, this I forgot to write the line. Where I just simply draw it containing a line and the point. So I just simply draw it. So it will be you find the normal. So you need the free point, fixed point, and direction vector. And next you find the normal vector. And lastly, you use this r dot n equals to a dot n. Okay, is it really long? So because this subtopic has many different types of asking method, but it's simple. You just need to remember. Just now you see the sixth question. You just use back one formula. This formula is very important, which is r dot n equals to a dot n. You just the most important. You just need this formula. You just need to find the fixed point and the normal vector only. This is the most important. Use any method to find this a and n come out, so you can solve this equation of plane. It's easy only. So let's go to the angle between two planes. So the vector equation, just now we have learned the vector equation of plane P1 is r dot n equals to a dot n. A dot n can be written as d also. The P2 is r dot n2 equals to d2. So the angle between P1 and P2, angle, you see the angle, you see these two plane between P1 and P2. Yeah, here. Can you see this? I'm drawing this blue color thing. The angle between these two planes, so become the angle between the two normals right here. So same, the angle between two planes will equals to the arc cos, the dot product between n1 and n2, and divide by the magnitude of n1 times n2. Yeah, and for this chapter, you just need to remember that to find the theta, you need to find this your arc cos the dot product, across the dot product and the multiplication of two magnitudes only. No matter for you need to calculate the angle of what thing. The angle between two lines or two planes or two vectors or any else, you just use this formula. Is it easy, right? Okay, so let's go to the question. Yeah, I have one question. Okay, two question. Okay, sorry. Okay, two question. So find the angle between two planes below. So I need to find the normal vector. Let me go back the equation. Yeah, the relationship between the plane and the normal equation. So if I write the A, B, and C as I, J, and K, I, J, and K, so it will be the normal vector. So go back. So N1 will be 2I minus J plus K. And the N2 is 3I plus J minus K. So I find the dot product of N1 and N2, so I will get 4. So the magnitude of N1, I will get sub 6. The magnitude of N2, I will get sub 11. So I across the 4 divide by sub 6 times sub 11, so I will get 60.5 degree. Yeah, it's simple only. Prove that the plates, these two planes are parallel. Okay, so how you prove it? So you need to find the angle between the two planes. So you find the normal. First you find the normal. 2I minus 3J minus K. Negative 6I plus 9J plus 3K. So I find the dot product. We'll get negative 42. The magnitude, sub 14 and sub 126. So I find get the theta will be 180. 80. So let's look back. Okay, look back the scalar product. So for the parallel vectors, the angle of the angle of between the vector will be 0 or 180. The 0 is the like parallel vectors, which is the same direction. 180 is the opposite direction, but parallel. So we use this theory. So since the angle between the two planes is 180, so the planes are parallel, but in opposite parallel. So let me draw C. Yeah, they are parallel, but just their normal vector in different side. One go down, one go up. Yeah, it's simple. It's for the angle, for asking an angle, it's simple only. Okay, so it's another study of the planes. So now we have learned the line and plane. So the next two subtopic, we will learn about the relationship between the line and plane. So we will learn the angle between line and the plane and their point intersection. So when a line sub a plane, the line I will write it as R equals to A plus dV. Okay. This A I forgot to write this because it's the vector. And the plane write it as pi. So R n equals to D. Okay. So when they sub, we will get the angle and the point of intersection, which for later. So the angle alpha between the line and the normal is given by this. It's the same. I don't want to say more. Just this equation always come out. Okay, since the theta and alpha are complementary angles, the complementary angles which the theta plus alpha will be 90. So you need to find the theta, so you just use 90 to minus the alpha. So we'll get the theta. Okay, so why you need to do more this step? So because you see the normal vector is the normal vector is the v is good just go up. So the angle you get between the v and n is not the angle between the line and plane. This the angle between the line and the normal only. You can see just up at here. So you need to do one more step, which use 90 to minus this alpha to get the real angle between line and plane. Okay, so let's go to the question. So first find the angle between the line x equals to 2, y minus 1 divided by 2, z minus 2 divided by 3, and this plane. So this plane I plus 2j plus k, this is the normal. So the v is, yeah, you see this x equals to 2. It cannot write it in the Cartesian form because it does not have t. Does not have t, so I cannot get the t come out. No t. So the a equals to 0. So this b equals to 2, c equals to 3. So the vector will be 2j plus 3k. The I does not need to write. So the dot product between v and n is 1. Magnitude of v is 13. Magnitude of n is 6. So I will get the alpha at cos of them, so become 83.5. The 83.5 is just the angle, eh, just the angle between this line and this normal only. So I need to find the angle at here. So I need to use 90 to minus 83.5, so I will get 6.5. So here's the answer. Yeah, for this topic, just ask like that only. So I just one example. So last we go to the point of intersection between the line and plane. So if the line pass through a plane, just now I say line pass through a plane has a point of intersection. Written as x, y, and z. So we need for this special a bit special. So you need to write this line in the parametric form. I write first. The line must in parametric form and the plane. The plane must in Cartesian form. A2x plus B2y plus C2z equals to D. Why? So because we need to substitute the line each x, y, and z. Yeah, the x, y, and z into this plane to find the value of t. So after I find the t, so I only can find this x equals to what, y equals to what, and z equals to what. So this number of x, y, z will be the point of intersection. Yeah, so let's go to the question. So find the intersection point between the line and this plane. Okay, so I write the line in the parametric form. Let the x, y, and z come out. And the pi, yeah, is in the Cartesian form, so I no need to write more. So I just sub the x, y, z. So I will get the t equals to 3. So I sub x equals to 2 plus 3 equals to 5, y equals to 7, and z equals to 2. So it's the intersection point. Yeah, it's just like that. 5, 7, and 2. It's not any special, just it's special as you need to use the write this length and pi in the parametric and Cartesian form. But the asking method just not so special, just ask like this, very direct. Okay, so here is end of the 5 by 4 and here's the end of chapter 5. So in next video, I will discuss the hot question, some hot question which come out from the past paper. So see you.